So we have done the preliminary analysis, and now we are going to find the domain of the function. The domain of the rational function will be all values excluding zeros of the denominator. Okay, so in our case we have f of x, and that is the reason why we have performed the simplification and factorization, because we want easier to see the zeros. And you can see that this equals 0 when x equals 1, and this equals 0 when x equals minus 1. This gives us the domain, that is the set of all real numbers excluding 1 and minus 1. So let's just write here domain D equals set of all real numbers excluding minus 1 and 1. So that's the domain. I'll highlight it here for the sake of completeness. Now, when we have excluded those values, a common question in these types of questions and in this context is, since obviously 1 and minus 1 are like critical values. Now the question is there finite limit of f when approaching 1 and minus 1? So these are the further steps of our analysis, and this will lead us to now continuity. So I will write here, now we seek continuity. So obviously the function except at 1 and minus 1, which are not in the domain, f of x is continuous on R without minus 1 and 1 as quotient of two continuous functions on the same set. So that means that apart from 1 and minus 1, function is continuous everywhere. So for example, if you want to find whether f, so what is the limit when x approaches 2 of f of x, you can simply put 2 cubed minus 1, 2 squared minus 1, which is 7 over 3. So that's a finite limit, and that is just f of 2. So that really means that the function is continuous on every value except 1 and minus 1. Now we need to see whether the points of discontinuity, which are 1 and minus 1, are maybe removable, or they are like essential discontinuity so that the limit doesn't exist. So we are just going now to say investigate the nature of points of discontinuity. Okay, so that's the task now. equals. So this is the task. And we have 2 points of discontinuity, 1 and -1. So case x equals, let's say, 1. Now let us go to our, again, definition of the function. So that is x minus 1, x squared plus x plus 1 over x minus 1, x plus 1. Now, and we know that x is different from 1, x is different from -1. When this is the case, so when under this assumption, we can cancel. So we obtain f of x is x squared plus x plus 1 over x plus 1. Again, under this assumption only. When we have this, now it is easy to see that limit when x approaches 1 of f of x equals x squared plus x plus 1 over x plus 1 is, we can evaluate, that is 1 squared plus 1 plus 1 over 1 plus 1, which is 3 over 2. What does this mean? This, so limit when x approaches 1 f of x equals 3 over 2, means that x equals 1 is removable discontinuity. So this is removable discontinuity. So, conclusion, x equals 1 is removable discontinuity. Okay, and I will highlight that. Okay. Now it remains to investigate. So case x equals -1. In this case, we can also use the simplified version because we know that x is different from 1 and -1 now. So that is x squared plus x plus 1 over x plus 1. And we want to know what is the limit when x approaches -1 of f of x. Here we are going to, because obviously at -1 there is discontinuity, we cannot put f of -1. Is, I will just say, not defined. Again, remember, f, even the simplified version, it is not defined for -1, so we cannot evaluate at -1. But let us see what is with the two-sided. So limit when x approaches -1 from right and when x approaches -1 from left. Now limit when x approaches -1 from right, f of x is, if you want, one easy way to see this is, so we have -1 here, and you can take -1 plus epsilon, where epsilon goes to 0. So instead of x, we will put f of -1 plus epsilon, and let epsilon go to 0. So that will be 1 plus epsilon squared plus minus 1 plus epsilon, and plus 1 minus 1 plus epsilon plus 1. And I'm leaving this for you as an exercise. You will see. So this goes, this is 1 minus 2 and so on. This goes to plus infinity, and this is your homework to show this. Okay, and here epsilon goes to 0. And limit when x approaches -1 from the left. So now you take minus 1 minus epsilon. F of x is limit when epsilon approaches 0 of f of minus 1 minus epsilon. And as homework, you can see that that will be negative infinity. Therefore, we can conclude that x equals -1 is a point of infinite discontinuity.